This video will introduce you to using arrays of objects. The programming project we're going to study is creating a deck of card objects. This is similar to Programming Project 7.7 in your textbook. After we complete this, you will be using this as a foundation for writing Programming Project number 5, a game of cards. So this presentation will walk you through the sample program that uses an array of objects, which consists of a deck of playing cards. Class card has a suit, which is either hearts, diamonds, clubs, or spades, and a value. The values 2 through 10 will be used to represent the cards 2 through 10. Value 11 we will use to represent a jack. Value 12 to represent a queen. Value 13 to represent a king, value 14 to represent an ace. We see two cards pictured here, the King of Hearts, so his value would be 13 and his suit would be hearts. And the Nine of Clubs, the suit would be clubs, the value would be 9. The deck consists of 52 card objects. These are unique cards because we are representing 2 through 10, Jack, Queen, King, and Ace for the 4 different suits. We will also keep track of the top of deck. That's an integer index, so we know which card in the deck is next to be dealt from the top of the deck. Here is a sample run after constructing our deck of 52 cards. If you look at this carefully, you will see there are 52 unique playing cards. The 2 through the ace of diamonds, then the 2 through the ace of hearts, then the 2 through the ace of spades, and finally the 2 through the ace of clubs. Let's get started with the program. We'll start by looking at the card class. We see that class card has an enumerated type declared for the suit that could be diamonds, hearts, spades, or clubs. So it has private member suit and private integer member value. The values will range from 2 through 14. Again, 2 through 10 corresponds to the face value of the card. 11 is used for the jack, 12 for the queen, 13 for the king, and 14 for the ace. Now those values were selected because for most card games, the ace is considered the highest card, with the king right behind it, then the queen, then the jack, and then 10 down through 2. So by numbering our values this way, it makes many card games easier to manage. The next 4 statements you see, those final chars, are the Unicode character representations for the symbols diamond, hearts, spades, and clubs that you saw on the output. So I used those inside the toString method to represent our cards with the unique character symbols for the different suits. Next, we see a default constructor that arbitrarily sets a card to the 7 of hearts. Now we don't want a deck of cards that has the 7 of hearts, but for our purposes, a value of 0, which would be the automatic default value given to a card if we didn't create our default constructor and assign it a value, really is not suitable, since the correct value could only be between 2 and 14. Right below the default constructor, we see a conversion constructor that accepts an input for the value and an input for the suit. Now we've talked about enumerated types and you've had a bit of practice with them now, but just as a reminder, by using the suit instead of a string, we have already nailed down the only valid values to be hearts, diamonds, clubs, or spades, which means nobody could construct a card with a suit that wasn't one of the valid 4 suits. Not so easy for the integer value. Certainly, since this accepts an integer, somebody could construct a card with a value that doesn't make sense for our program. So notice that the very first line of the constructor for this example filters out bad inputs for the value. If the value submitted for input V is less than 15 and the value V is greater than 1, well then it looks okay to us and we'll accept it. But if it's not within that range, we're giving them a message that there was an invalid card construction attempted and we're exiting the program. Let's scroll down a little bit and take a look at the setter methods and the getter methods. We have a set value. Again, we have to range check the input V to be sure that this is within the correct range of values. For this example, I chose to check the range in a little bit different way. There are many different ways. In this case, we're checking is the value greater than or equal to 2, and is it less than or equal to 14. Both of these checks, I'm going to scroll back down for a minute so we can see them both on the screen. Both of these checks are valid and do the exact same range checking for us. We've just constructed the expression in a different way. My first choice is the way we are doing it in the set value. But I did want to demonstrate it's not the only way. So if you think about constructing your check a little bit differently, as long as it is correct, it's fine. Okay, the accessor getValue just returns a copy of the value. So we know then that that could only return between 2 and 14. I'm scrolling down some more. Here's our set and get for the suit. Again, because we have used the enumerated type, we do not need to do any range checking on the set suit, and the get suit just returns a copy of the value of suit for the card. Let's take a look at the toString method. The toString needs to determine the value is between 2 and 10. It's just going to print out the value. That's the default case. Look at that carefully. So our initial string cval for card val is set to null. Then we check in a switch statement the value. If it's an 11, we are going to print a J for the jack. Case 12, Q for queen. Case 13, K for king. Case 14, A for ace. Everything else, 2 through value 10, will just correspond to the 2 through the 10 card. Right below that, we see that we are checking the suit. If the suit is hearts, we want to append that hearts Unicode character. Otherwise, if it's diamonds, append the diamonds Unicode character. Otherwise, if it's spades, append the spades Unicode character. Otherwise, if it's not hearts, diamonds, or spades, then it must be clubs. Notice I don't need to check if it's clubs. It must be clubs. And so I append the clubs Unicode character. These correspond to those constants we declared at the top of the class card. Finally, now that we have the card built with the value and its suit, we return that as a string. That is all of the code for class card. Now let's take a look at the deck class. In class deck, we defined a constant numCards. In this case, there will be 52 cards in our deck. Then we declare our deck array of cards, and we see that top card is indexed to keep track of what the next card in the deck will be. I'm going to scroll down a bit because we need to take a look at the constructor for deck. Pay attention to how construction happens with arrays of objects. We saw the declaration for our card deck up above. Now we see that we are instantiating 52 object references to card. So this will allocate the space for the 52 cards. And then we set the top card to 0. I have an ival equal to 0. Now the ival is going to be used to construct the card value. S suit is initially set to clubs. We will be using the S suit to set the card suit. We are going to use a for loop that ranges from 0 through 51, and we'll change the I value, that's our integer value for the value of the card, to be equal to I mod 13 plus 2. Now why are we choosing this? Well, remember, I is going from 0 to 51. We will need to have 4 different sets of cards with values 2 through 14. If I mod with 13, that will give me a result of 0 through 12. I need my cards to have values 2 through 14. So after I mod with 13, I add 2 to the value. This gives me the range of 2 through 14. That's setting the value of the 52 unique cards. The next statement is the switch statement that divides I by 13. When I divide by 13, going from 0 through 51, I will get 13 zeros, 13 ones, 13 twos, and 13 threes. These correspond to the suits. So remember, we're doing integer division here. 0 divided by 13 will be 0. When I get to I 13, 13 divided by 13 will be 1, which will give me the suit of hearts. So 13 through 25 will give me the hearts. Cards 26 through 38 will give me the spades, and cards 39 through 51 will give me the clubs. Look at that constructor carefully to be sure you understand it. The last line of code in our constructor invokes the card constructor, and it applies the ival and the suit, and for the 52 different cards, we will get the 52 unique ival S suit combinations. I'm going to run this because the code in the test card deck, let's take a look at it, creates a deck and then prints out the deck. So there it is, our unique set of 52 cards that corresponds to our method of construction for the deck. Walk through that code as necessary to see how this works. Just pick a few numbers between 0 and 51 and do the arithmetic and see how it corresponds to both the suit and the ival. Let's look at the two-string method for the deck. Starting with a default empty string, I have a for loop here for the 52 cards. If I mod 4 equals 0, I want to start a new line. The reason I'm doing this is I wanted the output to be 4 cards per line. After I print out 4 cards, I then start a new line. After the new line, we see SDeck is appended with a tab character and then deck sub I. Deck sub I is using the two-string method of the card class. So we get the corresponding ival and suit in terms of the Unicode character suit graphic. At the end, we print out another new line and return the string. These two strings are becoming more and more useful as our objects become more complex. All of the work is done inside the class, and that two-string method prints out our output of the 52 cards. Pretty nice. Scrolling down, we see a deal a card method. We also see a shuffle method. The deal a card returns a copy of the card that's on the top of the deck, and then it increments top card. As we deal a card, it is as though we are simulating taking the card off of the top of the deck and giving that to the calling part of the program that asked for a card to be dealt to it. Notice the return type is type card, and we're literally returning the card from the top of the deck and then incrementing top card. So the next time we deal a card, it will be the next card in the deck. We'll demonstrate that by adding code to test card deck in just a few minutes. Let's look at the shuffle. We use a random number generator. We create a temporary card, and we use 3 shuffles per card. So we see an outer loop going from 0 to less than 3. For each card in the deck, we swap it out with a different card in the deck. And we do that 3 times to shuffle the deck of cards. Then we reset top card to 0. So let's add those lines of code to test card deck. Let's do a mydeck.shuffle. And a systemout.println. Again, we should see the cards are now shuffled. And then let's do a systemout.println of my deck dot deal a card. That should print the top card from the deck. I'm going to copy and paste this 2 times. So this should print out the first 3 cards of the deck after we see it shuffled. Okay, let's run it. I'm going to scroll up. We see the initial construction of the deck before it is shuffled. Then right below it, we see the shuffled deck. And we deal the top 3 cards from the deck that corresponds to the King of Hearts, the 9 of Diamonds, and then the 3 of Diamonds. I will post a few forum questions next week that you could answer about this program. I hope you enjoy your next project where you will be using the deck of cards to play a card game. Happy coding!